2.1, question 9. Complete the table to show the structure of the organic product from each reaction of phenol. Okay, so the first reaction is phenol reacting with sodium hydroxide. Now, phenol is described as a weak acid, okay? And if this was structure of phenol, as an acid, it will lose H+, okay? Don't forget, phenol also have hydrogens, 5 hydrogens on this other carbon. But when it behaves as an acid, the acidic hydrogen ions is the one that is attached to the oxygen, all right? So this is a weak acid base reaction. So what do you think we will form or produce? A salt, okay, so what's the name of the salt? Sodium phenoxide, okay, so just imagine plucking off that H plus and then having an O minus, and a counter ion would be the Na plus. Phenol with sodium, same thing as a weak acid reacting with metal. They also mention organic product, so that means just the one that contains carbon and hydrogen, right? So things like water, that's an inorganic product, you don't need to include it, okay? The next one, acid with metal, also the same, you will produce a salt as well. And the salt will also be the same, sodium phenoxide and hydrogen gas. Okay. Next is phenol with this molecule. Do you remember what we call this ion? Does anyone remember what this ion is called? Starts with diazonium. Okay, diazonium ion, and it reacts with sodium hydroxide at 4 degrees Celsius, and this looks like what we call a coupling reaction. Okay, and if I just draw out phenol, OH, the two benzene rings, the one on the diazonium ion and the one on the phenol, will be coupled together. There will be a bridge, okay? And that bridge is formed by the diazo nitrogen bond, okay? Now, before I start drawing the molecule, I need to know which position does the OH in phenol activate. There's 1, 2, 3, 4, 5, 6. Does anyone remember OH group phenol? Which position is activated? 2, 4, 6. Okay, so it's usually activated on the 2, 4, 6 position. But for this reaction specifically, usually they like to direct it to the 4 position first, because they try to space out the 2 benzene rings from each other. Because if we attach it on the 2nd position, it will be too crowded. Okay, so how do we draw this product? I will rotate my phenol, the 1, 2, 3, 4, and that's where the new link or bridge is formed. Nitrogen with another nitrogen attached to the diazonium ion. Now my question is, how many bonds are there between the 2 nitrogen atoms? Double bond. Okay? So that if you put 3, That means you would have a positive charge somewhere. The nitrogen now has 4 bonds, okay? Now each nitrogen has only 3 bonds. And that is called a diazo compound. Okay, next. Reaction 4. Can anyone tell me the type of reaction? This was actually not covered in phenol, but covered in carboxylic acid. What reaction is this? Esterification, or there's another name? Condensation, okay? Or the type of mechanism is elimination reaction. So here we have an esterification process, or sometimes called condensation. If you want to look at the mechanism, it is the addition elimination mechanism. So it's like phenols reacting with carboxylic acid, but this is the cousin of carboxylic acid. Okay? So just to point out, that's the reactive, or that's the functional group. And it also mentions excess. So that means you can have more than one molecule of phenol, right? And phenol will react with both of both sides of the functional group. So if I just show one, phenol acting as a nucleophile would attack the slightly positive carbon. They don't ask for the mechanism, but I'll just show you. The double bond breaks, the double bond reform, and the carbon-chlorine bond breaks to form, let me try to color coordinate this. So we have that benzene ring in the middle. I'll start with the acyl chloride on the left. T double bond O, and that is where your phenol is. And that's an ester because COOC. Okay? And the other side, don't forget to complete my benzene ring, otherwise that would be wrong. C double bond O of the acyl chloride molecule will be retained because I break it and then I reform the double bond. But the new bond being formed is between carbon and oxygen. Are you all okay with this? So same reaction on this side. It says to identify two reactions from the table in which ethanol would behave in a similar way to phenol. So they want you to identify, out of the 4 reactions, ethanols can react with the same reagent. Okay, so let's have a look. Will ethanol react with sodium hydroxide? This is more to your AS revision. Will ethanol react with sodium hydroxide? Some unsure, no. Others, some yes. Will ethanol react with sodium? Yes. Okay, that's a confident yes. Correct. It will react with reaction. It will react the same way for reaction 2. It reacts with sodium, but it doesn't react with sodium hydroxide. Okay. Will alcohol react with diazonium ion? Well, we didn't learn this last year, and neither did we this year. Okay, so diazonium ion will only react with phenols at that particular condition. Will ethanol react with an acyl chloride? Yes, alcohols will react with acyl chloride. So the answer is reaction 2 and 4. Okay, so that means alcohols can react with sodium and acyl chloride. That is question 9. We will move on to question 11. Question 11 is mostly the explanation bit that I want to discuss. Okay, done with this one? Okay. And a question 11 here. Right, so K can also be synthesized from phenol C6H5OH. Okay, so that is K. And we've got the first reaction without looking at what the question is asking us. That is a metal acid reaction. Okay, weak acid, just to remind us that phenol is a weak acid, reacts with metal to form salt plus hydrogen gas, just like a normal inorganic acids. Reaction 2, excess bromine. So phenol is the more reactive version of benzene. If benzene were to react with bromine, you need a catalyst. What's the catalyst? Aluminium bromide, okay? And also it needs to be in anhydrous. It works at room temperature. But with phenol, bromine doesn't need a catalyst. You don't need to warm it. It just happens at room temperature. However, it's a more reactive reaction, so multi-substitution will happen. So you will be replacing more than one hydrogen on the benzene ring. The question is, where will the bromine be attached to on the benzene ring? You always have to think about the position that is being activated. Okay, so for phenol, which one? 2, 4, and 6. Okay, and that is what you will form. So OH is carbon number 1. 2 will be here, bromine, bromine, and bromine. Okay? If you just answer one bromine attached to phenol, it's wrong. Because it's so reactive that all the 3 possible or the 3 activated position of carbon will be substituted, all the hydrogens will be substituted with bromine. Okay, next question. Explain why phenol is a weaker acid than K. So this is K. There's that phenol functional group, and there's that carboxylic acid functional group. So we want to compare this molecule K versus phenol. Okay, well, we can look at the anion. For the stability of the anion will determine the acidity of a molecule. Okay, so if I turn this into the anion, it would be, this is probably O minus, but that is not our concern. Our concern is the COOH, which is the carboxylic acid, and anion, as an anion, it produces minus. Okay? Let's have a look at the COO minus group. What makes this carboxylate ion stable? There's a delocalization happening here. But how do we describe? The negative charge is being spread out. Yeah, it is being spread out to which part of the molecule? The COO. Okay, so that's why you will see sometimes they draw it like that. Okay, because there is delocalization. We don't learn about the delocalization in C double bond O, but the pi bond on the C double bond O is now delocalized throughout the COO group. So that's why the anion of the carboxylate is more stable, whereas on phenoxide, there is also localization, delocalization. This negative charge is being spread out throughout the benzene ring. However, what's the difference? You may argue, well, isn't the delocalization bigger in benzene ring compared to in the carboxylate ion group? This negative charge or the electron density is being pulled by the carbon atom. Whereas here, the electron density is being pulled by oxygen. What do we know about oxygen? It is highly electronegative. Okay? And electronegative means the tendency to push or attract electrons, to push or pull electrons. Electronegative. If an atom is highly electronegative, will it have the ability to pull or push an electron density? Pull. Pull electron density. Carbon, alkyl group, has the ability to push electron density, like electron donating. Okay, so oxygen here is acting like an electron withdrawing. So this oxygen say, well, come, give me your negative charge. Okay, spread it out to us. So this molecule is stabilized. Whereas here, carbon is not really that inviting, just like, just like a courtesy. Okay, carbon doesn't really like electron. It pushes electron away actually from itself. But this negative charge is being spread out in the molecule, but like not genuinely. Okay, they don't really want the electron density. Unlike oxygen, oxygen is highly electronegative. They want the negative charge. And that explains the difference in stability of the anions. This anion is more stable than the phenoxide. So if the anion is more stable, then it is more likely to be formed in aqueous solution. So if you form more anions, you form also more H+. And that tells you this is more acidic than the phenoxide. Okay? Explanation why phenol is a weaker acid than K. They would see all three for 2 marks. Okay, they want 3 points. The first point, I would say the carboxylate anion is more stable than phenoxide ion. 1 mark. Oh, sorry. You need 3 points, okay? Secondly, due to electron withdrawing effect of the electronegative oxygen in C double bond O. And lastly, more H plus being produced in solution. Additional point is to say the OH bond in COOH is weaker than in phenol. So if the OH bond is weaker, you release more H plus. Okay, same thing. Okay, so that's acidity. Next, we want to explain reactivity. Okay, so what's the difference between explaining acidity and the reactivity? First thing you need to remember, benzenes or aryl compounds in general will be attracted to electrophiles. Okay, electrophiles are species that are lacking in electrons, so it wants to receive electrons. Okay, that means it depends on how electron rich your benzene ring is. So I bring this to the other side. These rings will attract electrophiles, and you can see for phenol, you just need a dilute condition of nitric acid. You don't even need a catalyst. Whereas benzene, you need your reagent to be concentrated, and you also need a catalyst of concentrated sulfuric acid. So it already tells you that phenol is more reactive than benzene. The question is now, why? Okay. Before we look at the explanation, can you tell me, based on the reaction listed here, which one will attract the electrophiles more? The one with no condition or the one with a lot more condition needed? So electrophiles will be attracted without the condition in it. The electrophiles will be attracted to phenol or benzene more. Phenol. Okay, that's why you don't need a lot of condition. So this is more attractive to electrophile compared to benzene. Okay, and you can already see what's the difference between the phenol and the benzene is because of the presence of that oxygen. That oxygen has a lone pair. This ring is already electron rich, but the fact that the hydroxy group is there, it adds on to the electron density of the benzene ring. Okay, how? Well, you already know that there is a system or a network of delocalized system, pi delocalized system. This oxygen is now also a part of the delocalized system. So if you look at this benzene ring, there are 6 pi electrons. Now that oxygen is joining their group with additional 8 electrons, this benzene ring is now more, it has a higher electron density, so it attracts the electrophiles even better. Okay, that's why you do not need a lot of conditions for this reaction to react. How do we put that in words? For 3 marks again. First, we will talk about the attraction. We say that phenol attracts electrophile better for 1 mark. Secondly, we will talk about the lone pair of electrons. We say that the lone pair of electrons is delocalized into the benzene ring. It now becomes a part of the delocalized system. And because of this, the electron density in the ring increases. Okay? So we're talking about two different things when explaining acidity and explaining the reactivity. Okay? Acidity, we usually talk about which anion is more stable. As for reactivity of a benzene ring, we look at which one is which one has a higher electron density because it reacts with an electrophile. Just like hydrolysis just now, we looked at the carbon that would attract the nucleophile the most, right? The carbon with the slightly positive, uh, the one, the carbon with the higher delta plus will attract the nucleophile best. So when talking or looking at reactivity, you want to look at whether it attracts the nucleophile or the electrophile better. Because as we know in the mechanism of organic chemistry, the first attack usually involves the attack of either a nucleophile or electrophile, depending on the nature of that molecule. If that molecule is electron rich, then it reacts with an electrophile. If that molecule is electron deficient, then it reacts with a nucleophile. So it's always the opposite. Something which is electron rich reacts with something that is that is electron poor. Okay. All right. So I say that is all for today. Nina, can you please stop the recording? Thank you. So tomorrow we are going to look at March 19th.